To do part A, we need to do a Riemann sum where we use the sample points of the upper right corner of each square, and that is represented by our definition number 5, where we know the m equals 3, n equals 2, and from the equation z equals xy, we can change z to be f of x and y equals x times y. However, we are missing x sub ij, y sub ij, and delta a. In order to do the Riemann sum, we need to find the lengths and the heights of each square in the sum. In order to do that, we can take the endpoint subtracted by a starting point of each variable and divide it by the respective m or n. So for x, I can do 6 minus 0 divided by 3, which is equal to 2. And for y, I can do 4 minus 0 divided by 2 equals 2. So we know that there is a length of 2 and a height of 2 for each square. And from that, we can find that delta A is equal to 2 times 2, which is equal to 4. Now, we need to figure out what our coordinate points will be for each square. Since we know that the minimum value of x and y are 0 for both, we can imagine there is a square starting from 0, 0, with a length of 2, a height of 2, such that the upper right corner is at 2, 2. And now we can continue adding our lengths and our heights until we are at the boundary or outside the boundary. So we can add 2 to our length so that we are at 4, 2 and 6, 2. And 6 is the maximum x value we can have. And now we can add plus 2 to our height so that we are at 2, 4, 4, 4, and 6, 4. Now we know all our values that we can plug in to definition number 5. Can be approximated by the summation of I equals 1 to 3 with the summation of j equals 1 to 2 of f x sub I y sub j times 4. So we have the summation of f22 plus f42 plus f62 plus f24 plus f44 and f64. And this will all be multiplied by 4. Given that our function f of x and y is x times y, we have the values 4 plus 8 plus 12 plus 8 plus 16 plus 24, which is equal to 72 times 4, which is equal to 288. And that is our answer for part A. For part B, everything stays the same except for the coordinates we used. Instead of point at 2, 2, we will use a point starting from a square 0, 0 with a height of 2 and a length of 2 at the middle, which is 1, 1. We can still add a height of 2 or a length of 2 to find our coordinate points. So these will be the coordinate points that we are going to use in our midpoint formula. So we're going to plug in the points here. The summation of I equals 1 to 3, and with the summation of j equals 1 to 2 is equal to f x sub I with a bar and y bar sub j times 4. And we found our points to be 1, 1, plus 3, 1, plus 5, 1, plus 1, 3, plus 3, 3, plus 5, 3. Plugging that to our function, we get 1 plus 3 plus 5 plus 3 plus 9 plus 15. And that is equal to 36 times 4, which is equal to 144. So that is the answer to part